Right now, somewhere inside your lower back there is a tail. It's small. It's fused. It's made of bone. You call it your tailbone. You felt it every time you've fallen hard onto a chair. But you've never once used it to swing, balance, or communicate. It just sits there, quietly finished, at the base of your spine. The real answer to why it's there is far stranger than you think. For most of the animal kingdom, a tail is not optional. It's a tool. Cats use it to balance mid-air. Monkeys use it to hang from branches, grip vines, even pick up food. Dogs use it to signal fear, excitement, submission. A tail is communication, propulsion, and stability, wrapped into one moving limb. You had one too. Just not for very long. Around week 5 of development, every human embryo grows a tail. It has up to 12 vertebrae, extending past where your legs will eventually form. For about 2 weeks, you are, structurally, a tailed animal. Then by week 8, something happens. The cells in that tail begin to die on purpose. It's called apoptosis, programmed cell death, and it methodically dismantles the structure from the outside in. What's left gets pulled inward and fused into your coccyx, for tiny vertebrae locked together at the base of your spine. Why build something only to delete it days later? Because you didn't lose your tail. Your ancestors did. And the evidence for exactly how is written into your DNA. In 2021, a team led by geneticist Bo Xia at NYU Langone, working with evolutionary biologist Itai Yanai, went looking for the mutation responsible. They compared the genomes of tailed monkeys to tailless apes, humans included, and found something specific. A single stray piece of repetitive genetic material, called an ALU element, had inserted itself directly into a gene called TBXT. This gene controls tail development across nearly all vertebrates. That insertion didn't just weaken the gene. It changed how it was read entirely, causing the body to produce a shortened, altered version of the tail-building instructions. Xia's team estimates this mutation appeared in the common ancestor of apes somewhere between 20 and 25 million years ago. One genetic accident. Passed down through every ape lineage since, including yours. Here's the strange part. When Xia's team engineered mice to carry that same mutation, the mice lost their tails too, exactly as predicted. But something else showed up alongside it. A noticeably higher rate of neural tube defects, the same category of defect responsible for conditions like spina bifida in humans. Losing the tail may have come with a cost baked directly into the same piece of DNA. So why would evolution make that trade? Because around the same time this mutation appeared, the ancestors of apes were changing how they moved. Early primates lived by leaping and balancing along thin branches, and a tail was essential for that kind of movement, acting like a counterweight. But the ancestors of apes were shifting toward a slower, more deliberate style, climbing thicker branches, using their arms to swing and brachiate, relying on strength and grip instead of a balancing rod behind them. Charles Darwin noticed the coccyx more than a century before anyone found the gene behind it. In The Descent of Man, he pointed to it as one of his clearest examples of a vestigial structure, a leftover feature with no remaining function, evidence that humans were shaped by a long chain of ancestry rather than appearing fully formed. He didn't know about ALU elements or TBXT. He just noticed the bone and asked why it was still there if it did nothing. Once in a while, that ancient blueprint slips back into view. Doctors have documented rare cases of babies born with what's informally called a human tail, a soft, boneless flap of skin extending from the lower spine. It isn't a mutation reversal exactly. It's usually the apoptosis step failing to fully finish its job, the same demolition crew that dismantles your tail in the womb simply leaving a little scaffolding behind. These cases are almost always harmless and are typically removed surgically shortly after birth, which means the machinery to build a tail never actually left you. It's still sitting in your genome, fully capable of switching on. Every human alive briefly grows one, and every human alive spends the first trimester quietly dismantling it, piece by piece, before anyone even knows they exist. You can feel the last remnant of that process right now if you sit down and lean back slightly. That small, dense point of pressure at the base of your spine isn't a leftover accident with no purpose. It's an anchor point. Muscles and ligaments that once controlled the movement of a tail have been repurposed to stabilize your pelvis and support you when you sit. The tail didn't just disappear. It was rebuilt into something else, something you rely on every time you take a seat. So the next time you bruise your tailbone falling onto a hard chair, you're not just hurting a random bump of cartilage. You're bumping into 25 million years of inherited change. A single genetic accident in a distant ancestor, a trade-off written directly into the same DNA that shaped your spine, and a structure your own body still builds and then quietly erases before you're even born. You didn't lose your tail. You just finished growing past it.